Good morning, everyone. Today we'll discuss about the a very important topic related to calculus, that is set theory. Set theory. Now, the first definition is set. What is the definition of set? Set is a collection of well-defined object. Is a collection of well-defined object which are which are distinct from each other. It is a collection of well-defined. Well-defined means मान लो एक सेट के अंदर बहुत सारे एलिमेंट होंगे और देयर आर लार्ज देयर इज अ number of element in a group if all element have a same property. That means, for example, I am just taking an example, that is natural number. If you collect all natural number, that means 1 2 3, all these numbers having a property that is known as that, that is all these numbers are all these numbers are natural number. That means if you collect these elements in in order and apply a braces, then that is known as set. Set is a collection of well defined means if you say that the talented student stand up in the class, but here we are not defined that in which field. Those property which vary from person to person, that means that is not a well defined means those parameter which is fixed for every person, that parameter will not be vary person to person, that parameter being as a well defined. So set is a collection of well defined objects which are distinct from each other, means all elements are distinct to each other. And in addition, in this definition, set are usually denoted by capital letter. Capital A, capital B, capital C, dot dot dot, and each element each element are usually denoted by small a, small b. The second point is, if small a is an element of a set capital A, then we write A belongs to capital A. This is the symbol of belongs to. And if A does not belongs to A, that means A does not belongs to A. Means A element does not lies in the set capital A. Example, let's say a set capital A is given like this: A, comma B, comma C. That means A, B, C are the member of this set capital A, or we can say that small a belongs to capital A. I can say that B belongs to capital A. I can say that C belongs to capital A. Means these elements lies in the set capital A, or we can say that A small a is the member of set A. Standard notations. Standard notation. Capital N, a set of all natural number. Capital W, a set of capital Z, or capital I means a set of integer. Z plus or Z minus. A set of positive or negative integer. Q, a set of rational number. Q plus or Q minus means a set of positive or negative real number. P means a set of complex number. These are the notations which are used to represent a set of numbers, that is natural, whole, and rational, irrational, real, and complex. This is the notations. Any doubt at any point?
No, sir.
Now, the next heading of set is method to describing the set. Method. Method to describing a set. The first one is roster form or listing method or tabular form. RTL. RTL. Roster or tabular or listing method. In this method, in this method, a set is described. A set is describing by listing the element. By listing the element separated by commas. And enclosed within the braces. Within the braces. Now, for example, I'm taking an example, then you get. Let us consider a set of vowel of English alphabet. A set of vowel of English alphabet, that is A, comma, E, comma, I, comma, O, comma, U. All elements are in small letter. This is a representation of set in roster form or listing method or tabular method. Tabular form. Now another one is, that is set builder form. Or ruling method. What will you do in this method? In this method, we write down a property. We write down a property or rule which gives us all the element of the set. all the element of set. For example is capital A is equal to x is such that x is a vowel of English alphabet. So this here I had written the property of elements of a set. Here I can write the whole elements. I can write the whole I can write the property of all elements, which is common. X represent all these elements. Clear? Now this is a method of describing a set, that is roster or tabular or listing method. The second one is set builder or rolling method. Now this is the representation of the set. Now the next heading is type of set. The first one is empty set or null set or void set. A set containing no element. A set containing a set containing no element. It is denoted by phi or this one. The second one is singleton set. A set containing a single set, single element. Example, this one is a singleton set. This is the singleton set. Set having only one element. Finite set, a set containing finite number of element or no element. Example, this is finite set. This is also finite set. Note Write down an important note. Cardinal or order of a finite set. Order of a finite set. The number of element. The number of element in a given finite set. The number of element in a given finite set is called cardinal number. If capital A is a finite set, then cardinal number is denoted by n capital A. Example, A comma B comma C comma D. Because in the set there is four element. That's why n is equal to 4. Means order of set A is 4. Infinite set. A set containing infinite number of elements. A set containing infinite number of elements. That is infinite set. A set containing infinite number of elements, that is known as infinite set. A set containing finite number of elements, that is finite set. Now the next one is equivalent set. Equivalent set. Two sets are said to be equivalent if they have same number of elements. if they have same number of element. If n is equal to nb, example, what is equivalence? Let's say capital A is 1, 2, 3, 4, 5, and capital B is A, comma E, comma I, comma U, O, comma U. Then both are equivalent because n of capital A must be n of capital B is equal to how many elements are there in both set? 5 and 5. Then NA is equal to NB is equal to 5. Then this is the finite number. Okay. Now what is equal set? If I'm talking about equal set, that means the set having same element, same number of element and same element also. Two sets have to be equal. Are said to be equal if every element of A is a member of B and every element of B is a member of A. We can write A is equal to B. That means their coordinately may be equal and they have same element. They have same element. Suppose example, let's set A is equal to 1, 2, 3, and 4, and set B is equal to 2, 3, 1, and 4. Element can change their place, but number of element in both set must be equal and they have same element. And the place of element no matter. Here, for example, here 2 is in the second element. In set B, 2 is the first term. And in set A, 2 is the second term. This is third term or fourth term. So no matter in the set, the element are placed at which places there is no matter, but same element must be having in the set. That means 1, 2, 3, 4. There is 4 elements. Here is 2, 3, 1, 4. But their position, if their position will change, but they must be equal because same element are here and number their cardinality be equal. That means Na is equal to here Na is equal to Nb and elements are also same. That means these both set are equal. Note all all equal set are equivalent, but not vice versa. Means all equivalent are not equal. There is no necessity. But all equal set are equivalent. Now this is the type of set: infinite, finite, equal, equivalent, and so on. Now the next heading is subset and superset. What is subset? Let capital A and capital B be two set. Every element of A is an element of B, then and is an element of B, then capital is a subset of B. And B is called superset of A. And is written as is written as A is a subset of B. That we can write this one example. Superset is the here. Because each and every element of set A lies in B, that means A is the subset of B and B is the superset of A. Anyone who have any doubt? till now?
No, sir.
All these theory you got it? If you have any doubt at any point, just tell me. I will explain again. Now the power set of a set formed by all the subset a set formed by all the subset of a given set capital A is called power set of A. Example, let's say set A is 1 and 2. Number of subset, number of element in set A, let capital NA, sorry, NA, that is 2. Total number of subset 2 की power NA. This is formula 2 की power 2, that is 4. That means total number of subsets is 4. How can 4? Because 1 is null set and 2 is singleton set and last one is this set. There is a 4 subset 1, 2, 3 and 4. And the set of A has 4 subset. Now the power set of A will be power of set A is also a set, in which these set are treated as an element. 5, second element is 1, 2, 1 comma 2. This is a power set of a set which containing all the subset of that set which is treated as an elements of this set. That means this is known as the power set of A. Anyone who have any doubt? Or total number of subset, this is a formula, total number of subset that is equal to 2 to the power number of element in set capital. Now the next one is universal set. A set consisting of all possible element a set consisting of all possible element which occur under which occur under consideration is called a universal set. Example, let set A is here in the system of the set. U has a set which containing all these elements. That means U is the universal set of the system of set. Now the next one is proper subset. If capital A is a subset of B, and A does not is equal to B, then capital A is called proper subset of B. And we write means there is no equality proper subset. The next one is comparable set. Definition of proper subset. Example, let's say is set A 1, 2, 3, set B is 1, 2, 3. From here, A is the subset of B because A is completely lies in set B. That means A is the proper subset of B. There is a quality sign. That means in that case, capital A is represent a improper subset. Now the next is comparable set. Two set A and B are comparable. A is the subset B of B is the subset of A. Then A and B are comparable. Non-comparable for two set capital in capital B. If neither A is a subset of B, B is a subset of A, then A and B are called non-comparable set. Example, here A is neither the subset of B, B is now the subset of B. That means A and B are non-comparable. Non-comparable. Now the next heading is disjoint set. Two set capital and capital B are called disjoint if A and B have no element common. Both set A and B are a disjoint set. Now the next heading is Venn diagram. In a Venn diagram, the universal set is represented by a rectangular region, and its subset is represented by circle or a closed geometrical figure inside the rectangular region. Example, let's say this is a rectangle which represent a set. This is the geometrical representation of set. If a rectangle is here, then this represent a universal set. In a closed bracket, generally I'm taking a circle. This is the subset. This is A, this is U. Then any subset can be represented geometrically by the closed region inside the rectangle, which represent a universal set. Now the next one is operation on set. Union of set. Union of set. Write down the definition. The union of two set, capital A and B, denoted by A union B, is the set of all those is the set of all those elements which are either in capital A or in capital B or both capital A and capital B. Basically, A union B is also a set in which the element are from capital A or from capital B or from both capital A and capital B. These elements are lies in A union B. If I want to just draw the ge- geometrical Venn diagram of this union operation, let's say this is the first, this is the second. This is a set A, this is a set B, and this is a universal set. If I am talking about A union B, that means you will do paint at a time. means all region have only one layers of color. This is the A union B. I'm taking an example numerically. Let's set A is 1, 2, 3. A union B means 1, comma 2, comma 3, comma. This is A union B. Because here 1, 2, 3 lies in A, 4 is line 2, 3, 4 lies in B, and 4 is 2, 3 is line lies both A and B. That means this is the A union B. The element of this set either lies in A, either or lies in B, or lies both A and B. This is the collection of all those elements. The next one is laws of union of set. Laws of union of set. For any three set, we have A union phi is equal to A. Second one is U union A is equal to U. A union phi means a set capital is given and a null set. Then if you do a union operation, then you get capital A. This is known as identity law. This is known as universal law. Now the third one is A union A is equal to A. This is idempotent law. The fourth one is if A union B is equal to A union B is equal to B union A, that is commutative law. A union B union C is equal to A union B union C. That is associative law. These are the some fundamental properties related to union. Now the next one is intersection of two set. Now the next operation is intersection of sets. The intersection of two set capital A and capital B denoted by intersection B is a set of all those elements which are in common to both A and B. If A1, A2, AN is a finite family of set the intersection is denoted by AN. I'm taking an example of intersection of operation. What is the intersection B? That is 2, 3, 4. Those elements which are common in both the set. And intersection B is 2, 3, and 4. Any doubt? All of you? Those who have any doubt, just tell me. Na? Intersection of two sets. You will take common. Laws of intersection of two sets. Laws of intersection of two sets. Laws of intersection of two sets. For any three set A, B, and C, we have A intersection phi is equal to phi. U universal set. Intersection A is equal to A. Third one is A intersection A, that is equal to A. The fourth one is A intersection B must be equal to B intersection A. A intersection B union C is equal to, if you distribute this, A intersection B union C, um, I can write A intersection B bracket, sorry, this is the intersection. Now the sixth one is A intersection B union C is equal to A intersection B union A intersection will apply on C, then A intersection C. Now the seventh one is A union B intersection C means A union B intersection A union C. That means A union will be operated on B, A union will be operated on C. Or this intersection is here. Similarly, in this case, A intersection will operate B, A intersection will operate C. A intersection C, intersection B. Union is the middle point. If you have any doubt in the law, then just tell me which law you are. These law have names. And the first one is identity law, that is a universal law, that is the idempotent law, that is commutative law, that is the um, associative law. This is the intersection distributor over union. This is the union distributor over intersection. These are the names. Any doubt at any point? Now the next, I'm just writing all the laws, name of all the law. Intersection 5 means identity law. The second one is universal law. The third one is idempotent law. This is the commutative law. Associative law. This is the intersection distribute over union. Union distribute over intersection. These are the names of law. Now the third one is difference offset. Difference offset. For two set capital A and capital B, the difference A minus B is the set of all those elements of A which do not belong to B. I'm just represent by the help of Venn diagram difference of A and B. Let us say this is a rectangle. This is A and this is B. This is the reason which are only in A. This is the reason which are only in A. I can, this is known as A minus B. I'm talking about B minus A. Then what is B minus A? This reason is B minus A. And this reason is this yellowish reason is A intersection B. A intersection. I'm taking an example. How can you do minus in between two set? If you want to find out the value of A minus B, then A minus B means those element which lies only in A, not in B. That means A lies in only in A, B lies only in A, C lies both A and B. That so that we cannot take C or D both. Therefore, A minus B is AB. If I want to find out the value of B minus C, then those elements which are present only in B, that means that is E and F. C and D lies in both set A and B. Therefore, B minus A means E comma F. This is a difference of two set. I'm talking about symmetric difference of two set. For two set A and B, symmetric This is the symbol of symmetric difference. And I'm showing in Venn diagram. Symmetric difference means A minus B union B minus A. If this is A, this is B. No doubt this is a universal set. I'm painting those regions which belong to A minus B union B minus A. These are the reasons which are symmetric difference of A, symmetric difference of B. Laws of difference of set. Laws of difference of set. For any two set, A and B, we have A minus B is equal to A intersection B dash. B dash means complement of B. A minus B, in place of A minus B, I can write A intersection B dash. The second one is B minus A means B intersection A dash. The third law is A minus B is a subset of A, and the third one is B minus A is a subset of B. Now the fifth one is A minus B is equal to A. This implies by A intersection B must be phi. If A intersection be phi, then A minus B is equal to A. The sixth one is A minus B union B, that is A union B. You can draw the Venn diagram, and from there you can see all these properties. That means left hand side must be equal to right hand side. A minus B union B, that is A union B. Seventh one is A minus B intersection B is equal to phi. 8 1 is A minus B union B minus A. A minus B union B minus A. A union B minus A intersection B. Now the second one is if A, B, and C are any three set, then A minus B intersection C, A minus B union A minus C. If A minus operate on B, then we can write A minus B. A minus B operate on C, then we can write A minus C. This intersection will converted into union. This is a very important part of this property. That is, when minus operate, then intersection will be converted into union, and a union will be converted into intersection. Now the next one is if here A minus B union C, then A minus will operate on B, A minus B, and union will be converted into intersection A minus C. A minus B and A minus C. Now the third one is if A intersection B minus C, then A intersection will operate on B, minus will remaining as this is A intersection C. If A intersection B symmetric difference of C, then A intersection will operate on B, A intersection will operate on C, A intersection B symmetric difference of A intersection of C. These are the properties of the difference. Now, the next concept is after difference, I will explain about complement of set. I will explain about complement of set. See, complement of set. Capital A is a set with universal set. Then complement of set है denoted by A dash or AC. That is U minus A. Properties of complement of set A. I am taking a Venn diagram of complement of set A. Let's say this is A, this is U, then this one is A dash. This is the set A. Then the outside, these are the A dash. This is A dash. Now the properties of complement of a set. Properties of complement of set. The first one is A dash dash means A. I can write U minus A dash. Second one is A union A dash is equal to a universal set. Third one is A intersection A dash is equal to phi. Phi dash is U. U dash is equal to phi. And fifth one is if A union B whole dash is equal to U minus A union B. These are the properties related to complement. Now, some important point, which that important points is also known as satta. I'm taking about some sattas related to sets. See, every set is a subset of itself. Empty set is a subset of every set. For any set capital A, and its universal set is a subset of U. Capital is equal to phi, then power set has only one element. Power set has only one element. If A is equal to phi, then power set has only one element. That means NPA is equal to 1. Now the next sector is power set of any set is always a non-empty set. Suppose set A is equal to 1 comma 2. Power set of A is equal to phi 1 to 1. That means A belongs to PA. Set A belongs to PA, but not this will not be belong to this one. If the element belong any set, that means exactly that element will lies in. Here, set of A. Set of A means if you in place of A you can write 1 2 in braces, then this is another braces. That means there is two braces on left and right. Then there is no element here. In this case, 1 2 has one braces. In this case, 1 2 has two braces. That therefore this element is different from this. Therefore, set of A does not belongs to PA. A belongs to set A belongs to this because A is this one or this lies in PA. That means A belongs to PA. Now the next point is 6 point. If a set A has an element, if a set capital A has an element, then PA has PA has हेलो
हेलो।
बोलिए मैम।
12:30 तक ले लीजिए आप, 12:30 तक।
हम उधर हिना मैम से बात कीजिए, तो मेरा लेक्चर रहता है 12 से 12
मैं नहीं बोला।
ठीक। Then PA has, if a set capital A has an element, then PA has 2 raised to the power n elements. PA has 2 raised to the power n elements. I'm taking an example based on this. Let's say set A has 1, 2. Number of subset is the number of, if there is 2 element, then the number of element in PA is 1, 2, 3, 4. That means the number of element in PA is 2 raised to the power number of element in this, that is 2. According to this formula, the number of element in PA is 2 raised to the power 2, that is 4. Or you can count here 1, 2, 3, and 4. Now the next one is the set, this one is not a null set. The set this is not a null set. It is a set containing one element. One element. Got it? These are the some important points related to set theory. So some important formulas, some important formulae related to set theory result on numbers of element in a set. NA union V is equal to NA plus NV minus NA intersection B. A union B is equal to NA plus NB if set A and B are disjoint. Third one is NA minus B is equal to NA minus NA intersection B. NV minus NA intersection B. The fifth one is N asymmetric difference of V is equal to N intersection V. The sixth one is A union B union C is equal to NA plus NB plus NC minus NA intersection V minus NB intersection C minus NA intersection C plus NA intersection V intersection C. And number of element in exactly two of the set. Exactly of set that is equal to B intersection C plus N A intersection C minus 3 times of N A intersection B intersection C. Now the next one is number of element in exactly one of the set A, B and C. Exactly. Number of element in exactly. बोलो मैम.
V1 में लेके देख रहे.
हेलो.
हेलो सर,
बोलो.
आज पे है ना, आज पे 11 सीबीएसई भी आपको ही लेना है सर. 11 सीबीएसई. हाँ. कब तक है दुआ कर 12 से 1 कर 1 मिनट 2 बजे तक.
हेलो.
हेलो, 12 से 2 तक सर.
पूरा टाइम टेबल बदल रहे हैं आप.
मैं सर आज भी चल रहा हूँ लेकर के कर रहे.
हाँ.
तो शेड्यूल है ना,
हाँ.
एक सुबह का जो शेड्यूल है ना, वो तो आप इंडिया सर की जगह पे, तो टेंशन नहीं. अभी ये थोड़ा चेंज हुआ है, तो आप जो है वो वहीं पे रहेंगे.
कितने बजे तक रहना है इधर?
ठीक है ना सर.
ठीक है चलो.
11 से 8 से आपको दे दिया.
मैम मगर गुलाम सर के साथ क्या हुआ मुझे मॉन्ट
सर उनको तो 11 में आई करना. ठीक है.
चलो ठीक भाई. Okay, Nivedita. एक minute. The number of elements in exactly one of the set of the set ABC is equal to NC minus 2 times of NA intersection B minus 2 times of NB intersection C minus 2 times of NA intersection C plus 3 times of N intersection B intersection C. Okay, from tomorrow I will continue from here, and also I will take some more examples based on this theory. Okay, okay, that's all. Bye everyone. If you have any doubt, just tell me. Navita, are you have any doubt?
No, sir.
Okay, from tomorrow I will do a lot of questions. Then you understood all these theory. Okay, bye.
Thank you, sir. Bye.
Welcome.